Here is a question for our competitive examination in physics, and this question is regarding projectile motion. The question is asked by a strange student, so I don't know his name. He sent this question for me to solve. Now I'm having two different ways of solving this question. So the question is, a particle is thrown at some angle with horizontal from point P. It falls at C as shown. The triangles OAC and OBC are shown in the figure. The angle of projection from the horizontal is. So we have to find what? Angle of projection. So what is actually the angle of projection in any such a picture of a projectile motion? So the projectile angle means the tangent which is drawn at the point of projection and the horizontal line, that is what we draw. So this is our angle of projection, right? So angle of projection, angle of projection. So we have to find this angle of projection, and we are given with the four different options what you are seeing on the screen. And be careful about the details we are having. So a projectile which is thrown in this picture uh, will come to the point A, which is at a height of 10 centimeter and a horizontal distance of 10 centimeter. As it moves further in its projectile motion, it reaches another point B, whose vertical height is 5 centimeter and horizontal distance is 20 centimeter. So we already know using some basic mathematics the heights what we measure, right? So the heights what we measure is usually taken as y, and the horizontal distance, right? So this horizontal distance is usually considered as our x. So we are having some basic equation for this. The very basic equation for any such a projectile motion we use in class 11 is a y equals some tan theta multiplied by x plus, and we are having something in numerator and denominator, so it is minus g divided by 2 times v square cos square theta. Let me put these stuff in brackets, which is then multiplied by x square. This is one of the equation. Otherwise, I can also use y equals tan theta multiplied by x, and in the bracket I should write 1 minus x divided by r. So r stands for the range. Range is nothing but the total distance traveled horizontally, right? So from this point O and to this point, which is C in our given picture. So this distance becomes our r, which is called range. Well, so we got to know each and every parameter in our equations. So let us move further. So I use the first method, means this equation. Okay, I'm using this equation now. So what I can do now is, you should keep every details given in the picture in your mind. Okay, so because I have to go and up and down every time, so deal with it. Otherwise, it becomes very difficult for me. So now, see, uh, in the equation y equals tan theta into x plus something that's in bracket minus g divided by 2 times v square cos square theta into x. I'm using this equation. So in this method, so in this I call method 1. Okay, so I'm having two different points, right? So for point A, in the given picture, what I should put? I should put x equals 10 centimeter, and how much is y? So y is also 10 centimeter. So once I use these two points in my upper equation. So I get what? 10. So of course 10 is 10 centimeter, which is equals tan theta multiplied by 10. So this x is also in centimeters. So we don't write centimeter every time in this equation. And in the bracket, I should write minus g divided by 2 times v square cos square theta. And what I should write outside, it is x square, which is 10 square, right? So it is 10 square. We are seeing 10 as common on LHS as well as RHS. We shall remove 110. So means 1 equals. So what I should write? Tan theta plus the same stuff in the bracket minus g divided by 2 times v square cos square theta, right? Now it is multiplied by only 1 times 10. So this is the thing I get when I deal with the point A. So this is my equation 1. Okay, so now for point B. Okay, so if you have the picture in your mind, just repeat it in your mind. So for B, so x should be 20 centimeter, which is our horizontal distance. And how much is y? Y is 5 centimeter. So that's a given thing in our picture. Okay, so 20 centimeter is horizontal, that is x, and 5 centimeter is vertical distance. So observing these parameters, so now go to the equation. So y is 5, so which is equals tan theta times what? So it is our x is 20 plus minus g divided by how much I should write? So it is minus 2 times v square cos square theta. We are doing nothing to this part of the equation. So now I should write 20 times, right? So 20 is squared. So if you want, you can keep this equation as it is. You can call this equation 2. So now what I have to do, I have to divide these two equations. Now equation 2, let me say equation 2 is divided by equation 1, because on the LHS of equation 2 we are having a bigger number than the LHS in our first equation, right? So that's why I'm making what? I'm dividing the second equation from the first equation. So be careful about division. So on left hand side we are having 5 and 1 respectively from equations 2 and 1. So this is equals. So what I should write? I should write, otherwise I'll do one more thing which is quite easier. So what I can do is I simply make little change. Okay, a little change which could be helpful to us. So now I do what? I simply change my pen ink color. So from equation 1, right? So from 1 you can write this part of the equation, the next step. So here itself, but I'm having no space, so that's why I'm writing here. So from 1, what I can write? I can write minus g divided by 2 times v square cos square theta. It's quite easier. Okay, multiplied by 10, which is equals 1 minus tan theta. This is my first equation. From where I got? I got this from this stuff. Okay, so from here I have written this one. So now what I do, I go for the next equation, that is from point B. Okay, so from what I say, some 2, my previous equation 2. So it is here, right? So what I should write from here, so I'm writing here is a minus g divided by 2 times v square cos square theta multiplied by 20 times square, right? 20 square, which is equals 5 minus tan theta. So now it becomes my second equation. So this is our second equation. So it is very easier and convenient. Okay, so see how. So now what I have to do, I have to divide these two equation. All right. So now divide any of the equation. Okay. So now equation 1 divided by equation 2. So on left hand side, we are going to neglect the bracket term, which is minus g divided by 2v square cos by theta, because these two things are common. Okay, so when we divide, these two stuff will go cancelled. So what I get 10 divided by 20 square. If I'm right, it is right. So this is equals 1 minus. Okay, so 1 minus, so what I should write, it is tan theta. It is tan theta. So somewhere I lost one thing, I think so. Yes, of course, 20. I missed the 20 here. It should be written 20. Okay, so divide by 5 times 5 minus tan theta into 20. So now it is right. Okay, so I forgotten to write the 20 here in second equation. Well, so observing these things correctly, so what I can do now, so I'm having this much. So it is 1 divided by how much? It is 40. Is it right? So it is 400 and 1 times 10. So it cancelled. It is 1 by 40. So 1 minus tan theta divided by, so what I got? It is 5 minus tan theta times 20. So in the next part of the solution, so we'll make some cross multiplication. So on making cross multiplication, it is 5 minus tan theta into 20. So this is equals 40 times. The bracket term is 1 minus tan theta. Right. So if you solve this, 5 minus tan theta into 20. So this equals 40 minus tan theta into 40. So on bringing like terms means the tan theta term on one side. So I'll get what? So tan theta into 40 minus tan theta into 20. This equals, it is 40 minus 5. So we'll take out tan theta as a common term. This multiplied by 40 minus 20. This equals 35. Right. So in my next step, I write what? Tan theta, which is multiplied by 20, which equals 35. Okay. So you better to solve it further very easily. So now tan theta is equals how much? It is 35 divided by 20. So now the both terms are divisible by it is 5. Right. So both are divided by 5. So this is also divisible and this is also divisible by 5. So I get what? So tan theta is equals 7 5s are 35 and 5 4s are 20. 5 4s are 20. So I need theta. So angle of projection is theta. So my answer is tan inverse of 7 divided by 4. So this is the answer for this question in method 1. Right. So where is this option? So tan theta, theta inverse 7 by 4 is my this answer. Tan inverse 7 by 4 is option B, which comes correct in method 1. So let us go with the second method. Okay. So where is my second method? My second method is from the second part of the equation, this one. Okay. Here my second method goes. So method 2. Well, so here in this part of the solution, we have to go step by step again for the point A. For point A, what we have to put? We already know. So x equals 10 and y equals 10. So then what do we get? It is 10 equals tan theta into 10. In the bracket, I get 1 minus 10 divided by r. You can solve it further. Means here is 110, here is another 10. So it is 1 equals tan times theta, tan theta times 1 minus 10 divided by r. So this is my first equation, I call it. Well, so on solving this much, we'll go further. What we have to do is for point B, now solve for point B. So for point B, so in our point B, what we have to put? We have to put x equals 20 and y equals 5. So when you put this much details here, so in our equation, the second equation, we'll get what? 5 equals tan theta times 30, 20, and in the bracket it is 1 minus 20 divided by r. Even you can solve this further. 5 ones are and 5 fours are. So further I get what? 1 equals tan theta multiplied by 4, and in the bracket it is 1 minus 20 divided by r. This is my second equation. So once I got these two equations, so what I will do, I now divide both equation again. So now equation 1 divided by equation number 2. Otherwise you can equate the two equations because on left hand side we are having 1. Okay, we'll do it. It's very easy. So for that, so what I am saying, I said what? I said the LHS is a 1 for equation 2 and LHS is a 1 for equation 1. So that's why we can equate RHS. Equating RHS of 1 and 2. What we get? We get tan theta, which is multiplied by 1 minus 10 divided by r. This is equals tan theta into 4, which is multiplied by 1 minus 20 divided by r. So once we observe this much further, so we can simply cancel the term tan theta. So we get what? 1 minus 10 divided by r, which is equals 4 times 1 minus 20 divided by r. You can even solve this further. So in your own way, this is 4 minus, it is 80 divided by r. Right. So going further, what I may get? I may get and rearranging. So I do 80 divided by r minus 10 divided by r, bringing the terms containing r on left hand side and without r on right hand side. So it is 70 by r. This equals 3. Else I get r equals 70 divided by 3 centimeters. So I get what? I get r. But I don't need r in this question. I need what? Actually, I need theta, the angle of projection. So I'm using either of the equations of 1 and 2 in the second method. I'm using the first equation, that is 1 equals tan theta multiplied by 1 minus 10 divided by r, where I know the letter r, the value of r is known. So from 1 in method 2, what I use? 1 equals tan theta, right? In the bracket, it is 1 minus. It is 10 divided by, how much is r? R is 70 by 3. Okay. So this is 1 equals tan theta, and in the bracket, I get 1 minus 30 by 70, right? It is 1 minus 30 by 70. So further, so it is 1 equals tan theta. In the bracket, I get 70 minus 30 divided by 70. I'm taking LCM. Right. So this is 1 equals tan theta. Uh, in the bracket, it becomes 40 by 70, right? So this bracket term becomes how much? So this bracket term becomes 4 divided by 7. And on making some rearrangement, you get tan theta is equals 7 divided by 4. So else, so our angle theta is tan inverse 7 divided by 4. So again, we are getting the same answer what we got in our first method, right? So this is our answer in first method, and this is our answer in method 2, second method, right? Method 2. So that's all.